Every device you hold, every vehicle that hums past you on the street, and every satellite orbiting in the cold vacuum of space relies on a single, aging promise. That promise is the lithium-ion battery, a technology that has served us well, but is reaching its absolute physical limits. Imagine for a moment a world where that limit is shattered, where energy is no longer a constraint but a liberated resource. Today, we are going to peel back the curtain on a claim so audacious it could either save the future or become the greatest mirage of the 21st century. Before we dive into the heart of this mystery, I invite you to consider how your life would change if energy were truly infinite. If you value deep investigations into the technologies shaping our tomorrow, please take a moment to subscribe and join our community of thinkers. The stage for this revelation was the Consumer Electronics Show, known to the world as CES, in the year 2025. Amidst the neon lights and the frantic energy of Las Vegas, a company called Donut Lab stepped into the spotlight with a declaration that stopped the industry in its tracks. They did not just announce a better battery. They announced a revolutionary shift in the very fabric of energy storage. Their claims were specific, quantifiable, and frankly unbelievable by any current scientific standard. They spoke of an energy density of 400 watt-hours per kilogram, which is nearly double what you find in the most advanced electric vehicles today. If this were true, it would mean a car could drive twice as far on the same weight, or weigh half as much, while maintaining its range. But the energy density was only the beginning of the story. They promised a full charge in just 5 minutes, effectively matching the time it takes to fill a tank of gasoline. For a decade, the slow charging time of electric vehicles has been the primary barrier to global adoption, the friction point that keeps people tethered to internal combustion. Furthermore, they claimed a lifespan of 100,000 cycles, a number so high it defies common logic. To put that into perspective, if you charged your car every single day, the battery would last for more than 270 years. We are talking about a component that would outlive the vehicle, the owner, and perhaps even the infrastructure it drives on. When a claim is this monumental, the natural response of any informed mind is immediate and intense scrutiny. We have seen countless startups promise the world and deliver nothing but empty prototypes and broken investor dreams. However, Donut Lab is not a typical vaporware entity drifting through the halls of Silicon Valley. They are an established company that already produces high-performance electric motors used in real-world applications. This existing credibility is the anchor that prevents their claims from being dismissed as mere fantasy. It forces us to look closer, to look past the marketing, and to ask if they have actually found the hidden key to the universe's energy problems. As someone who has spent years in the academic trenches of solid-state battery research, I approach their booth with a mixture of hope and heavy skepticism. In the world of high-stakes technology, the gap between a laboratory breakthrough and a mass-produced product is a valley of death. Most innovations die in that valley, unable to scale or unable to survive the harsh reality of the consumer market. My goal was to see if Donut Lab had truly built a bridge across that divide or if they were simply painting a beautiful picture of a bridge that wasn't there. The investigation began not with what they were showing, but with what they were choosing to hide from the public eye. The first red flag appeared the moment I laid eyes on the physical display at their exhibition stand. Instead of showing the actual, functioning cells that were supposed to be changing the world, they presented three-dimensional printed mock-ups. These were plastic shells, hollow representations of a future that remained unseen and untouched. In the world of hardware, seeing is believing, and the absence of a live, working cell is often the first sign of a narrative that is ahead of its reality. When I questioned the executives about the specific chemistry or the proprietary manufacturing process, the shutters came down instantly. They refused to discuss the most critical details that would allow a scientist to verify their claims. This wall of silence turned my investigation from a technical review into a process of forensic inference. If they would not tell me what was inside the box, I had to look at the box itself and the way they intended to build it. The representatives claimed that their battery technology was incredibly flexible, capable of being manufactured in almost any shape imaginable. They even suggested snowflake-like geometries, which is a radical departure from the rigid rectangles and cylinders we are accustomed to. They mentioned that while they currently use a pouch format, the system is modular and does not require the massive, multi-billion-dollar gigafactories that companies like Tesla rely on. This focus on shape and modularity provides a significant clue to the underlying architecture. Traditional batteries use a jelly roll construction, where materials are wound tightly together, making them difficult to reshape without compromising safety or performance. Donut Lab's claims suggest a stacked layer architecture, something much more common in experimental solid-state systems. By stacking layers like a deck of cards, you can theoretically cut and mold the battery into unconventional spaces within a vehicle's chassis. This would allow engineers to utilize every cubic centimeter of a car's frame, but it still doesn't explain how they achieved those impossible performance numbers. The most confusing data came from their video presentations showing the battery under a high-speed charge. In the video, the data revealed a constant current and a constant voltage from a 5% state of charge all the way up to 80%. To a battery engineer, this is deeply unusual and defies the standard behavior of lithium-based systems. Normally, as a battery fills up, the internal resistance increases and the current must be tapered down to prevent overheating or damage. Charging at an 8C rate, which means full capacity in 7.5 minutes, while maintaining a flat voltage of 4.2 volts, is a technical anomaly. When I confronted the Donut Lab team about this 4.2 volt ceiling, which is the signature voltage of lithium chemistry, I received a shock. They looked me in the eye and stated quite clearly that there is no lithium in their system whatsoever. Furthermore, they claimed that the voltage of their cells could be tuned almost arbitrarily to match any existing application. This was the pivotal moment of the investigation where the pieces of the puzzle began to shift into a new configuration. If there is no lithium and if the voltage is tunable, then we are likely not looking at a chemical battery in the traditional sense. This led me to develop what I call the capacitor hypothesis. If you look at the evidence, the extreme cycle life, the 5-minute charging, the shape flexibility, and the lack of lithium, everything points toward an electrostatic capacitor. Capacitors store energy in an electric field rather than through a chemical reaction, which allows them to move energy incredibly fast and last almost forever. However, there is a massive problem with this theory: energy density. The state-of-the-art for capacitors is nowhere near 400 watt-hours per kilogram. In fact, they are usually 10 to 20 times less dense than lithium batteries. To find the truth, I had to dig deeper into the shadows of the supply chain, which led me to a Finnish company called Nordic Nano. This company specializes in screen-printed nanotechnology and has been working on moldable, thin-film energy storage solutions. Their documentation describes something called a bipolar electrostatic capacitor, a sophisticated device that uses nanostructures to store massive amounts of charge. Interestingly, the performance metrics in the Nordic Nano literature match the Donut Lab claims almost perfectly. The pieces of the puzzle were no longer just fitting. They were snapping into place with a definitive click. If Donut Lab is indeed using a form of advanced nanotechnology from Nordic Nano, it explains why they can be so vague about the chemistry. They aren't building a battery. They are building a massive high-density capacitor disguised as a battery. This would be a genuine breakthrough in material science, but it also opens up a cavernous gap in technical plausibility. To reach 400 watt-hours per kilogram with a capacitor would require a leap in science that we haven't seen in decades. It would mean they have solved the problem of dielectric breakdown and surface area at a scale that the rest of the world's laboratories have yet to touch. The leap from a small laboratory-scale thin-film capacitor to a gigawatt-hour production line for global transport is gargantuan. In a lab, you can control every variable, but in a factory, you have to deal with contaminants, vibrations, and the sheer physics of mass production. There is a visible and worrying gap between what is being announced today and what can be reliably manufactured tomorrow. As an investigator, I find myself in a state of emotional conflict because I personally know some of the engineers working at Donut Lab. These are competent, intelligent people who are unlikely to knowingly participate in a massive public fraud. This complicates the judgment significantly, as history shows us that even the best engineers can be misled by the promises of their own suppliers. If these claims eventually collapse under the weight of reality, the consequences will ripple far beyond a single company's stock price. It would create intense, unfair pressure on competitors who are doing honest, incremental work. It would distort the market and potentially cause a tech winter for energy storage, where investors become too afraid to back genuine innovations. The stakes of this announcement extend to the very heart of the electric vehicle ecosystem and the public's trust in a green future. For now, the verdict remains suspended in a state of cautious observation. I am not ready to call this a revolution, nor am I ready to call it a scam. Instead, I urge every observer to maintain a posture of informed skepticism and wait for the only thing that matters: independent verification. We are expecting teardowns of their technology from third-party partners, such as Verge Motorcycles, in the near future. Only when a neutral scientist opens the cell, measures the discharge curve, and confirms the absence of lithium will we know the truth. Until then, we must be hopeful but unconvinced, refusing to gamble our future on a promise that hasn't been proven. As we conclude this journey into the heart of the energy mystery, I want to leave you with a question to ponder. If you were given a technology that could last for 200 years, would you change the way you live today, or would you simply find a way to consume more? Our relationship with energy is not just a technical problem. It is a reflection of our values as a civilization. I wish you all great health and the clarity to see through the noise of the modern world. If you found this analysis valuable, please subscribe to the channel and share your thoughts in the comments below. Your perspective is the fuel that keeps this conversation moving forward. Thank you for your time, and until next time, keep looking deeper.